Hello class, this is Mr. Chang and we're doing Unit 1, Lesson 3 on Logical Reasoning and Set Theory. And this class and the next class, we will learn a tool which is called Venn diagram. So we are doing the same thing, we're learning about a set theory with and, or not. You still remember the symbol? When you have something, a set and another set, do we draw a U or the inverted U? And is intersection, so it's like this. And or is union. And not is you draw a bar on top. Like if you have an A, draw a bar on top. Okay? Or like A prime or A prime. Okay, so that's not. Okay, so we're doing the same thing, but now we are learning a tool which is called Venn diagram, which is a visual aid to help us. So it will make things easier. So I hope you love it. So let's look at the example. We have this example in our last lesson. We have two sets A and B. They are both defined to be natural number less than 20. That will be the universal set. And then there's some condition. One set is divisible by 3, the other set is divisible by 5. So like we can answer the questions like just divisible by 3, there will be 3, 6, 9, 12, 15, 18, right? Divisible by 5, 5, 10, 15. How about 3 and 5? Have to be divided by both. So there's only one number divisible by 3 and 5, which is 15. 3 or 5, between all the 3 and all the 5s, multiple will work. So 3, 6, 9, 12, 18 will be part of the set, and also 5, 10, 15. Now, we can put those information in a Venn diagram. Here we go. This is what's a Venn diagram look like. A Venn diagram will have a rectangular box which would represent everything in this whole set. So that's your universal set. So the whole rectangle is your universal set. And then inside you have two circles, one for A and one for B, and then you make them overlap. So the idea is some element belong to just A, some belong to just B, and some belong to both. Then you write it there. And then some doesn't belong to any of the A and B, then you put it on the outside. So there are 4 regions for you to put numbers. Okay, so let's look at here. So again, what is A? A is anything divisible by 3. So look at what's inside A. You have 3, 6, 9, 12, 15, 18. All the number divisible by 3 are inside this circle. And all the number divisible by 5 are inside this circle. And there's one common element, 15, that is divisible by both. That's why it's there. It's in the middle. Then how about the rest of number, 1 to 19? If they're not inside the circle, then they are out. They're on the outside. So this Venn diagram is a visual representation and organization of all the numbers that meet the set requirement or not, and then you just put it together. Alright, so the Venn diagram is pretty cool tool, it's pretty fun, and you can see all the elements, so you won't miss anything, it's all there. Now, let's look at the following. So all the Venn diagram, you can see, is drawn in a similar way, a rectangle, and inside there's 2 circles with parts overlapping. What is the intersection of the 2 sets? Just the part that is common. What is the union of 2 sets? You're adding the 2 sets together. This is the part that is common to both of them. And what is the complement of set A? Now it's just set A here. So you look at set A is a circle. Now complement means not. So not A is anything outside A. So when you do this part, you just focus on the A, ignore the B. Just focus on the A. So part of the B will be not A, but part of it will still be the common part that they share, the intersection will still be. Alright, so that's complement. Alright, then we're going to use the following to answer the question. So we have the same picture from previous page. What is A shade set A? Okay, shade set A. Okay, let's shade set A. How many elements are there? 1, 2, 3, 4, 5, 6. Alright? And then, well, they want you to list set A. Oh, do we want to do that? Are we serious? Okay. Let's do that. And then I'll do that for B. B is smaller, so you write B is equal to, right? You use curly bracket to state a set, and you just put things in comma. Somehow the comma between 5 and 10 didn't show. The number of elements in B, there are there's 3 of them. Okay, shade the area B. Here we go. Shade the area not A, so everything outside. Okay, I don't want to write the list, it's too long. So the total 19 numbers, take away 6 of them, so there are 13 numbers. Everything outside B, so which is here. The total free B, right, free number, there's total 19 number in this set. Because anything, and then all the number less than 20, so not including 20, so that's 19. The number of B prime is 19 minus 3. There are 16 elements that is not in B. Okay, what is this symbol? Can someone tell me? Right? Is it union or intersection? How about that? Union is U, easy to remember. Intersection is that. Intersection is just this. A and B, there's only one number that is both A and B. When there's only one number, you still put it in a curly bracket. It's a set of just one number. But then here, ooh, wow, new stuff. Ignore that long line there. Okay, so A or B. A or B means just either A or B. It doesn't have to be both. As long as you're in one set, you do it. Okay, let me put it in order. So 9, 10, right? Like I'm picking order. And then you have 12, and the next one there's a common one is 15, and then there's 18. So the total 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. Right there. 8 elements here. Good. Okay, so far so good, right? Ooh, wow, look at that. Not A intersecting B. Let's think about it. Not A. Now, you can use a different color. It may help you. Let's say I use red for the not A, and then I do the B, and then now think of the intersection. So now you superimpose the two shaded region. The part that is not A, but then is B will be here. Right? This part is B, and then it's not A. That will be the answer. So take some time to understand this example. Here, A, O, union, B. Okay, now when you union is easy. Union is easy to see because A, you just circle, color anything A, right? And then B, not B, so color anything not B. And then union is just adding them together, so you don't need to erase anything. For the intersection, after you do that, you need to take the common one. So here we go. Okay. Oh, look at that. The animation is so fun. Now, next one. Wow, not A, intersect not B. Okay, let's think. Not A is everything outside. Not B is everything outside. And then I want the common one, so it's just things on the outside. Not A and not B. So these are the things on the outside. Not A intersect not B. Not A is not A or not B. Okay, not A, everything outside, and then B outside. The only thing that area that's not touching is, okay, like for example, this is not B, right? Let's look at this. This is not B, and then not A is there's more. Oops, not B. There'll be more. Yeah, as well. Okay, so the only part that remain will be the part in between. So I just erase this part. The reason I need to do that is the limitation of the software. So I need to override it. But now, this should be the answer. Only the middle part is out. Oh, wow, this is different. You first think of intersection of A and B, which is just the 15, right? Just the part inside. And then you take the complement of that. So everything outside. Oh. So we have a conclusion, right? This is the same as that. Where we see these two are the same. Special rule. And then you do this. Okay, A and B union, which is the thing here, and then you take the outside, which is here. It's the same as that. Wow, the same as that. Oh, special rule. So it looks like we have some special rule here. So from the demonstration, we can see from the above Venn diagram, okay, that's what I show, right? A intersect B complement is equal to A complement or B complement, right? Union with B complement. And A union B complement is same as A complement and B complement. Special rule. Okay, so we can put a star next to them. Okay, let's answer some example. Okay, this is given. So given. So when it's given, you don't need to argue about that. It's just given. You don't need to ask why is it that case. This is given. Okay, just use it. What's P? P is 1, 2, 8, 9, 10. Okay, here we go. 1, 2, 8, 9, 10. Now when you see that curly bracket, it's kind of inviting you to fill in the list. Q is 1, 7, 10. 1, 7, 10, 29. Okay, so those are the elements. They want a list of elements. P and Q. What number are both P and Q? Only 1 and 2. So again, you put a curly bracket there because your answer will be a set of number. P or Q. Oh, there's a long list. Oh, I don't want to do that. Oh, come on. Okay, 7, 8, 9, 10. Okay. Not P. Okay, anything beyond P. So 7, 11, 16, 29. Now you can try this yourself and then you can check my answer. Okay. Maybe I'll do it. I'll fill out all the answer and then you check it. Okay. Okay, Puff, here's the answer. You can check it. And let me know if you have any question or if I make any mistake, let me know. And then which two pairs are the same? This is same as that. Okay. So take your time to read through them. Okay. So a Venn diagram can also be used to represent the number of elements in each set and not the individual element, as the next class example illustrates. Okay, so now be careful. This one, all the numbers are the actual sets, okay? It's the elements. But here is a different representation. It just represents the number of people in the group. So let's read the following example. So now these are number, not elements. The diagram displays the number of students who are members of social, which means SLC, the number who are in the yearbook. So these are number of people. There are 12 people, or total 15 people in SLC, 10 people in the yearbook, and 3 of them are in both. They're super busy. How many students are on the student council? So 12 plus 3 is 15, right? Like in here, you don't have a set of 2 elements, 3 and 12. Those are not elements. Those are not elements. Those are number of people. On both, well, there are 3 people on both committee. It's crazy. On yearbook, but not on student council. Okay, well, 7 of them. They're just in yearbook, but they're not doing student council. On student council or yearbook, well, then you add up all of them. They're either the 3, you don't double count them. So you just add them all together, the answer is 22. So there are 22 students, they are either on student council or yearbook. Now let's try that ourselves. Okay, using a Venn diagram. So Venn diagram is a really good way to organize information. So you have a 20 student, okay? Now we don't write 20 yet. Let's take the information. 15 take math. Now we don't write that down yet because we don't know how many also take social. 12 take social, but 10 take both. Okay, where do I put 10? Okay, you need to take the information one at a time. Don't be too hurried to put the number inside. Put the number that you can put for solidly, like 10, right? You can put it here. 10 people take both and math and science. Now, if 15 take math and 10 take both, how many of people just take math? 15 minus 10. Yeah, you're right, it's 5, right? Total, there are 15 people taking math. And then total, there are 12 people taking social, though, so it's put it here. So I done this little information. Finally, if you look at the number, that's 17. But how many students are there in the homeroom? There's 20. So what happened to the remaining 3? They didn't take math or social at all. So you actually put this number last. Do you see? How many students take neither math nor social? The answer is 3 people doing something else. So you see how Venn diagram could be really useful and powerful, but then filling in the Venn diagram could be challenging. Okay, so that's my example for today. I'll see you next time. Bye.